Hello, good evening. Good evening to everyone. And thank you, Bharti, for giving me an opportunity to share my views on the topic like electronics and experimental methods, which is the part of physics net and set syllabus. So again, I thanks to Mr. Rajiv Gandhi from the Bharti who is taking pain to organize my sessions on a very particular time. And once again, thank you, Rajiv sir. So, friends, as we have seen various aspects of the quantum mechanics, and now we are shifting from quantum mechanics to electronics, and some of the experimental methods. So, we'll discuss some basic in today's session, and then we'll move ahead for the advances in electronics. So, in that way, we'll be taking more than 5 6 sessions on this particular topic. So, friends, as we know, when we are dealing with electronics, then we know we are using number of components. So but before moving towards the basics of everything or the syllabus of the net and set, so let me just share with you how do we differ the electronics and electrical. So I hope there are number of participants those who are online. So can you share what is the basic difference between electronics and electrical? How do we distinguish these two? So where the electronic starts? Can anyone? I'm just waiting on link. So you can write in a chat and then yes. So friends, I got one response in a chat. So basic difference, yes, that's true. So the when we are talking about electrical, then we are always applying the Ohm's law, as everybody knows. The Ohm's law, the like simple or the mathematical form of the Ohm's law is V is equal to IR. Means whenever we are applying, when we are applying the potential difference, then there is a flow of current through the conductor. And again, if we but that flow of current is always directly proportional to the applied potential difference. But again, in like a broader sense, or if we see the Ohm's law appropriately or the exactly, then the statement of the Ohm's law is that so long as physical condition of the conductor remains same, then and then only the potential difference applied across the conductor is directly proportional to the current flowing through it. What does it means? Ki Ohm's law will be true provided the condition will be the same. Okay, the results of the Ohm's law will be always same if we are just we are able to maintain the conditions or the similar conditions. So now this is what the case for the electrical. So where we are applying mostly AC, even though in some cases we can apply the DC, but like broadly we can say when we are applying the AC with the one phase circuit or the three phase circuit, and again there are different arrangement how to connect and all like that. But friends, when we are trying to shift or when we are trying to discuss about the electronics or the electronic devices, then we know the devices like a laptop or the computer or the television or the radio, we can consider as a electronic devices. We are not considering as a electrical devices. Why? The reason is that whenever we are trying to use these all devices, then we are using the power supply in between these two. So even though if we are using the laptop, then we are using the power supply which is connected to laptop, and because of that we can run the laptop, or that may charge the battery also. Then in that way the DC, like direct current or the power supply, differs the electronic from the electrical. And that is what the crux between these two branches. And again, you may be knowing, if we see the engineering, then engineering also having these two branches. So one is electronics, another one is the electrical engineering, and that is what the broader classifications for them. Now if we want to discuss about electronics, then we know we just really blaze with the types of the material we called as a semiconductor. Not only semiconductor, but we want the conductor, we want the semiconductor, as well as we want the insulator. So but again, the mostly we are using semiconductor, even though dielectrics also we are using. So as simply just I have shown, I have put one integrated circuit on very first slide. And what does it shows? So if we see this particular integrated circuit or the ICs, not only the IC, it's a basically PCB. Okay, printed circuit board where IC and like a capacitor, then the diodes, and again transistors are mounted. So friends, so now you can see here, electronics means this is what the electronic circuit we can say. So friends, whenever we are talking about electronics, as I told you, we want to focus on semiconductor. Why semiconductor? Because we know when we are using the electronic components, then the first and the priormost component of the electronics is the diode. And as we know, diode can be made up of the semiconducting materials. So diode is, we are having different types of the diode, PN junction diode, we call it as a semiconductor diode, or we are having the LED, we are having the photodiode or the tunnel diode and all. But out of which, like a basic PN junction diode is most important, which that particular diode can always convert your AC to DC. That is why I am saying here the diode plays a very vital role to convert AC to DC, and then accordingly we are having the half wave rectifier, and that process we call it the rectifications, conversion of AC to DC. Then again we are having like a one diode if we are using, then we call it the half wave rectifier. If we are using the two diodes, then we call it as a full wave rectifier. And if we are using the four diodes, then we call it as a bridge rectifiers. And why we are going from one diode to two diode to four diode? Reason is that we want to increase the efficiency and we want to decrease the ripple factor. So these are the two reasons. Because of that, we are just moving from one diode to four diode. Again, after that, so after again, if we are converting AC to DC with the help of diode, but again, we are not getting the pure DC. So again, if we want to just get the pure DC, then we use some circuit, we call it the RC circuit or the filter circuit, an L section or the pi section filter. And after that, we are using like some components like a Zener diode. We call it as a means to create the regulated power supply, and we call it as ZRPS. So Zener regulated power supply. If we use the ICs to regulate the power, then we call it as a like a electronically regulated power supply. So in that way, we are having different power supplies, and that can be used for the purposes in the field of electronics. And always, that is why I'm saying here ki everything or these all things are depending upon the power supply. And that is why, or that is one device, like power supply is the device which segregates electrical to electronics. So now with this note, we will be just turning to next slide so that we can discuss more aspects about the electronics. So in your syllabus, you can see like this is the syllabus for the basic, and then we can go for the advanced. So the here we can see the semiconductor devices in which we are having the diode. So just before some time we have discussed basic some of the things. Then like junctions, then the transistors, then the field effect devices, homo and heterojunction devices, that also we can create. Device structure, device characteristics, and the frequency dependence and its applications. Another case is we can discuss about the optoelectronic devices, as everybody knows, like photovoltaics or the solar cell, photodetectors, or the LEDs. So these can be considered as the optoelectronic devices. So we are having this type of the devices also. Then another category of the like simply ICs basically. So that is again made up of, or we can say, or we can consider as the electronic components. So operational amplifiers and their applications. So as you may be knowing, operational amplifiers are like a means a very excellent device, rather we say, because we need not connect number of stages of the simple transistor like a NPN or PNP to convert or to create the amplifier. So operational amplifier gives us the more advantages as compared to the amplifier which can be created or developed with the help of the PNP or the NPN transistors or some of the FET MOSFET like. Again, the digital techniques and applications. So as we are having the registers, then the counters, comparators, and like that, there are certain similar circuits. Then analog to digital and digital to analog converters. Then we are having microprocessor and microcontroller basis. Then data interpretation and analysis in electronics, precision and accuracy. Then again, we are having error analysis, propagation of errors, least square fitting. So these are all things we will be trying to discuss. in 2 or 3 lectures, and then we'll be moving for the advances. So when we are just trying to discuss any of the electronics, then as I told you, so the basic of any of the electronics or electrical circuit is the Ohm's law. And in case of Ohm's law, as I told you, V is equal to IR. Or again, I am repeating the statement. It is not the complete statement. V is equal to IR provided the like a condition of the conductor remains constant. Like a physical condition of the conductor remains constant. So in that way, we can define or we can state the Ohm's law. So long as the physical condition of the conductor remains constant, then potential difference applied across the conductor is directly proportional to the current flowing through it. So here V is the voltage, I is the current that we are measuring in ampere, R is the resistance that we are measuring in ohm, C is the capacitance that we are just always measuring in farads, L is the inductance and that we are measuring in Henry. So in that way, you can see V is equal to IR, that is the Ohm's law. And then that can be written as, if we want to written in terms of that inductor, then we can write it V is equal to L dL by dt. So again, in terms of power, as we know, power is most important in any of the circuit. Power is nothing but the product of voltage and current. So simply product of voltage and current is I into V. But again, we can write this like V square upon R, and always we can write this as like a I square R also. And again, if we are considering, or if we want to measure the temperature by using any like a conducting or the conducting wires, then also this kind of the relationship will be useful. Then resistors and inductors in series. So how do we connect the resistors and inductors in series? Then if we are connecting 5 resistors in series, then how the effective resistance will be there. So that we know the R1 plus R2 plus R3 plus R5 is equal to RS if it is in series. But if it is in parallel, then as we know, 1 upon R1 plus 1 upon R2, 1 upon R3, like that. But instead of that, if we are using the capacitor in parallel or capacitor in series, so the relationship is reverse that of the resistors. So resistors and inductors in parallel and capacitors in series add according to, so that we can add as per the requirement, as per the need. So any question? So if you have any question, any basic question, you can write in a chat. Any question? Okay, no question. Shall I proceed? So now here you can see, as I have discussed, if we are just shifting from electrical to electronics, we require the batteries or the power supplies. Power supply is also considered as a battery. But again, we know we can use some cells or the ready-made battery, as we know. So that simply that is also that can be used. Like here you can see the example of 6 ampere of 1.5 volt battery indicates 0.25 25 ohm output impedance. So whatever it may be, so whenever we are just trying, impedance is nothing but the total resistance offered by the circuit. It's not like means whatever the circuit we have, so every component has its own resistance, and if we add entire resistance, then we can calculate the total resistance offered by the circuit, and that is what we call as a impedance. So simply we can see this. Then now let us come to this. The most important parameter is power supplies and regulation. So, as simply as I have mentioned in a very first slide, as I have discussed the basics, basic difference in between electrical and electronics engineering, or the like a branches like electrical and electronics. So that always differ each other from the only application of power supply. And now you can see a power supply typically starts with a transformer. Now, if I just wish to say, what are the major components of power supply, or the how power supply can be? So simply, just I want to use the pen. Yeah. So in any of them is simply you can see we are having 230 volt Okay, 230 volt imagine करते हैं अपन कि 230 volt AC we have, and our target is to convert like a 12 volt DC. What is our target? We have to convert 12 volt, we can say regulated DC. Instead of simple DC, we can see we have to convert. So 12 volt regulated DC. So that is what our purpose. Okay. So now, how do we convert it? So the first function can be done by the transformer. सबसे पहला काम कौन करेगा? Transformer. So what is the function of transformer? So transformer can convert this 230 volt AC to 12 volt AC. That is what our requirement, but not DC. After that, what will happen? After this transformer, what can we use here? We can use diode as a rectifier. So that is what here we have to use, diode, and as rectifier. And then as I told you, there are different types of the rectifier, like a half wave, full wave, bridge rectifier, and with the help of that we can convert DC. But again, it's not the pure DC. So this is means there are some ripples, some components of ACs are remain present. Now to remove the components of AC, what we do? We can use here filter circuit. क्या यूज करेंगे यहाँ पे अपन? फिल्टर सर्किट यूज करेंगे. एंड फिल्टर सर्किट may be made up of like a, you can see RC or simply the like a pi section or the L section filter circuit, which gives us the DC. And again means here you can get a pure DC, but again it is not the regulated. Okay, here with the help of that we may get the pure DC, but not the regulated. And to get the 12 volt regulated power supply, we can use the Zener diode in reverse bias mode or the ICs, and accordingly we called as ZRPS or the electronically regulated power supply. So this is the simplest way to create any of the power supply from AC to DC. So now simply let me just conclude from this with the help of this slides. Like our power supply is typically starts with a transformer. So is this, are you agree with that? Yes, yes or no? Yes or no? No? So here you can see power supply always begin with the transformer. Then a knock means like a step down transformer. Again, always you remember this transformer is a step down transformer. And again, we can use center tap. And again, it depends key how do we want to create the power supply. If we want to take two different outputs, then also we can use the different transformers. So I hope now you got the difference, means where we shift from electrical to electronics, and in that way now we have the electronics. Now we want to discuss about the component or the electronic component, and the first component, as I told you, that is what the diode. This is the PN junction diode. Okay, in reality, ये जो आपको black color का दिख रहा है, this is the diode. But the symbol wise, the above one is the diode, where we can see P and N type material. Here also you can see silver band gives us the N, this gives us the P. Here this big portion gives us the P, this gives us the N. Here also the way by which we can symbolize the PN junction diode. And as I told you, the PN junction diode is nothing but the first electronic compound or the first semiconducting components. And if we see the characteristics of this, then the characteristics of any of the PN junction diode is straight line any line. So this is a VI characteristics. You can see here VI characteristic of PN junction diode is like that. So in forward bias, you can see this is the origin. So the current flowing through the diode is like that. And if we just draw the tangent here, then this voltage can be considered as a cut-in voltage. And that cut-in voltage is the voltage at which any of the semiconducting device starts working. And if it is made up of silicon, then approximate value of cut-in voltage is 0.7 volt. It's a 0.77 volt. And if it is made up of germanium, then it is zero point 0.3 volt. So in that way, we can have the cut-in voltage. And again, if we see the reverse bias, so here that current is in milliampere. Okay, this voltage is in volt, but if we see the reverse bias current, that is always in microampere. So very few or the very less current flows through the diode when it is operated in a reverse bias mode. So that is why we can say that this diode is not made for the reverse bias. This diode is made for the forward bias, made to operate in a forward bias, not in a reverse bias. So in that way, we can get the characteristics of the PN junction diode, and that characteristics is mostly useful for making the rectifier or for making the power supply. Now again, here we can see how diode can be made. So simply, as I have discussed, diodes are made up of the semiconductors, usually silicon or germanium. Any of the semiconductors can be used for that. Then essentially a stack of p dope and n dope silicon to form a p junction. So this is not the way कि आप एक p type material और n type उसको connect कर रहे हैं, ऐसे नहीं होगा. So if we are taking p type material, then we are growing the n type layer into the same material. Then and then only PN junction can be formed. Otherwise, what will happen? That diode cannot work. So in that way, we have to see the PN junction diode. So then again, doping means what? Basically, as we know, if we are just trying to use the elemental semiconductors are like silicon and germanium, then we know it doesn't have typical applications. So to increase like or just to modulate the band gap, the gap between the valence band and conduction band, what we do, we are adding the N type or the P type impurities, and accordingly we can have the P type material and the N type material. So doping means the deliberate impurities that contribute extra electrons and dope or the holes for the electrons. And accordingly, we know we are having the means if we are having negative charges, then we call it the holes. If we are having positive charges, then negative charges, then it is called as the electrons. And if we are having positive charges, we consider it as a holes. And again, when we are just operating PN junction diode with the forward bias, then what will happen? Means from p type material the holes will start moving, then from n type material electron will start moving, and in between these two there is a formation of the recombination, or the recombination region will takes place. And because of this, again we can get the typical applications of the PN junction diode as a rectifier. Then again, likewise, here we are having P and N. Again, if we connect the P type material to this, suppose if we are just adding here one more P type material like that, and if we just connect it, then again now here P and P, now it is called as a transistor. Earlier it was diode, now if I have added one more, which means that it is a transistor, and it may be PNP or the NPN. And this type of the transistor, we call it as a BJT, bipolar junction transistor, and it has applications for the amplification of the signal. So this is mostly preferred for the amplification of the signal. Now another type of the diode we can discuss here, and that is the LED, that everybody knows, like light emitting diode. And simply we can see the symbol of LED, and this is the in reality everybody knows how LEDs are. Again, it's a diode, but simply which emits the light. And the main difference is material is more exotic than silicon used in ordinary diodes. There are so many materials. Nowadays, there are n number of or the plenty of materials which are used to get the like white LEDs or like a red LED or yellow or like a blue LEDs or like a green LEDs and all. So it depends the which material we are just coating on that, and these materials can be considered or can be known as a phosphor material. PHOR, phosphor. So phosphor is the category of the material or the optical material which emits the light. So everybody must note down that this material is called as the phosphor material which emits the light, and that is being coated on this particular substrate you can see here. And that substrate, when we are just passing the current, very less current or very few current, you can see here 2 volt drop. So So then also we can have the emission of light. So when electron flows through LED, less energy by emitting a photon of light rather than vibrating lattice like heat. So LED's efficiency is 30% compared to incandescent bulb at 10%. So as we know, so earlier we were using like incandescent lamp, and everybody knows when we are using the tungsten filament, then how it can generate the heat. Means mostly energy is just going dissipated to create the heat. But here, if we are using LED, then there is no emission of the heat. So that is why it is called as a cold emission. Whereas if we are using like a tungsten filament, then it is called as a hot emission. And efficiency of the LED is also 30% in okay, in comparison to tungsten filament. And that is why nowadays mostly preferred device is the LED. And again, LED is not only used for lighting purposes, but as we know, so the panel of the television is made up of LED. So in that way, LEDs can be used for as used at a several places. So must supply current limiting resistor in series. So figure on, you can see 2 volt drop across the LED, aim for 1 to 10 milliampere of the current. Simply we can see. Now, here, if you see the waveform, so just simply for your understanding, we have shown the waveform. One is you can see the input voltage, like that is the AC. And here you can see the half wave rectification. It's not a full wave rectification because here we have used the single diode. We haven't used the two diode. If we use the two diode, then we can get a full wave rectifications. So simply you can see AC provides a means for us to distribute electrical power, but most devices actually want DC. So the most of the devices like a laptop or your television wants the DC. They are not working appropriately on AC. And that is why we are more interested in DC. And that is why the categorization, as I have mentioned earlier, so that is the biggest categorization which categorize electrical to electrical. So then again, simply here you can see the bulbs, toasters, heaters, fans, don't care. So plug straight in. So simply these devices can be considered as electrical devices. We cannot see these devices as the electronic devices. But we are having some of the sophisticated devices, as I have mentioned, like television, like a laptop or the radio, or like similar kind of the devices. The sophisticated devices care because they have diodes and transistors, and that requires a certain polarity. So rather than oscillating polarity derived from the AC, because AC is, as we know, the frequency of AC means is 50 hertz, whereas the frequency of DC is 0. And that is why if we want to use the component like diode and transistors, we are just forced to use the DC instead of the AC. So this is why battery orientation matters in most of the electronics. So that is why in most of the electronic circuitry, we are using battery. Battery is nothing but the power supply. We are not using the alternating current. So use diodes to rectify AC signal. Like simplest half wave rectifier uses one diode. You can see here. Diode only conducts when input voltage is positive. But if it is in negative cycle, then it doesn't conduct. And that's why you can see here the half wave rectification can be seen in a black colored picture, like voltage seen by the load. So again, if we want to do better, so as I have mentioned earlier, there are types of the rectifier like a half wave, full wave, and the bridge rectifier. So if we want the better, doing better, then what we are using, we can use the full wave diode, full wave diode, or the full wave rectifiers, or even the bridge rectifier. So friends, here you can see in this figure. So the shown is the bridge rectifier. It is not the full wave. So here also we are using the source of the AC. Then again, here you can see how it is connected, and this is the waveform of the AC, and this is the converted DC. At the end, you can see. So here, what we are using basically, so diode in the rectifying circuit simply prevented the negative swing of voltage from conducting. So here only conducts the positive swing. Here there is a complete cut of the negative one, but this waste half the available cycle. So also very irregular, bumpy, far from a good DC source. But by using four diodes, you can recover the negative swing. Means if we use the four diode, then we can rectify the positive as well as the negative also. And that is why if we see the output of the DC is always straight line, and that is what expected for many devices. So here you can see full wave dual supply, means from which we can get the two outputs. And here the voltage is seen by the loads. So you can see here and can buy pre-packaged diode bridges. So here as we are using the four different diodes, but instead of that nowadays we are having the like a diodes are packed like that, and that is mostly preferred instead of using the four diodes. So by grounding the center tap, here we can see the center tap, we have center tap of the transformer, you can see that is grounded here, and we have used the two outputs, okay, of the step down transformer. We have two opposite AC sources, and the diode bridge now presents plus and negative voltages relative to ground. So each can be separately smooth or the regulated, and cutting out diodes A and D makes a half wave rectifier. Here we can see this A and D makes a half wave rectifier. So this is what the rectification. Then again, as I have mentioned earlier, if we are just trying to rectify the signal or trying to rectify anything, but then it is not pure. So, but at the end, if we wish to use the converted DC for any of the electronic circuit, then what we have to use? So we have to just filter it out, and the filtration is most important part in any of the electronic devices, and that can be done with the help of, as I have mentioned, with the help of L section filter or the pi section filter. So here for doing that, simply some of the basics we are doing, like by grounding the center tap, we have two opposite AC sources. The diode bridge now presents positive and negative voltages related to ground. So each can be separately smooth or regulated. Cutting out diodes A and D makes a half wave rectifier. So smoothing out the bumps, as I have mentioned. So here you can see that bumps we have to smooth out. So that, and that can be done with the help of capacitor. That can be done with the help of this. You can see I was mentioning RC, resistor and capacitor circuit. So still a bumpy ride, but we can smooth this out with a capacitor, and capacitors have capacity for storing the charges. Okay, that can store the charges, and that can just bypass the components of ACs which are remain present, and because of that we can get only the DCs. So acts like a reservoir to supply the current during low spots, and voltage regulator smooths out remaining ripples, and because of that we can get the continuous DC. Then again the question arises, how smooth is smooth, how much we have to rectify, how much we have to regulate it, means not the regulate. Again here we are just smoothing. So simply here you can see an RC circuit has a time constant. So like a T is equal to RC. Then again we can do the analysis of the circuit. Then we can have the phasor diagrams and all. And then on the basis of that we can calculate how smooth is smooth. So it's a simple example. Then again here also we are coming to this key regulating the voltage, like the unregulated ripple voltage may not be at the value you want. What we want the regulated voltage, and for this regulated voltage, as I have mentioned, one of the specific diode which we can use, that is a Zener diode, and the Zener diode can be used in a reverse bias mode to get the regulated voltage, and that depends on the transformer. Suppose like we want 15 volt or DC, then we can use a transformer which gives us the like a 230 or the 250 volt AC to 15 volt AC. So you could use a voltage divider to set the voltage, then but it would like a drop under load. So output impedance, I mean, these are the parameters which we have to taken in consideration. So now, as I have mentioned in previous slide, just I have said we can use the Zener diode as a regulator, but here, okay, in reality we have used the Zener diode. And again, Zener diode is electronic compound that is made up of the semiconductor material. So now this Zener diode can regulate the voltage. And if we see the characteristics of Zener diode, then it looks like that. So if we use Zener diode in forward condition, then it must work like a PN junction diode or the semiconductor diode. But in reverse bias mode, here you can see we can get a Zener breakdown voltage. And at this voltage, at Zener breakdown voltage, we can use this Zener diode as a voltage regulator. And that is what peculiar application of the Zener diode. And that gives us the regulated voltage so that we can protect many devices can run smoothly with the help of regulated voltage instead of the unregulated one. So Zener diodes break down at some reverse voltage and can buy at specific breakdown voltages. You can see, as long as same current goes through the Zener, it will work. So good for rough regulation. Again, it's not good. So better to use the electronic circuits or the ICs for the better regulations. But earlier people were using this Zener diode as a voltage regulator. And these are the certain conditions that we have to maintain to get the regulation from the Zener diode. So again, as I have mentioned, the ICs, voltage regulator ICs. So there are certain ICs. With the help of that, also we can regulate the power supply, and that power supply we call it electronically regulated power supplies. So friends, you can see how many components are there in a single IC. So that ICs contains the resistors, capacitors, diodes, transistors, and these are the connections made inside the IC. So IC, you can see this is the IC which can use for the regulation purpose. So now here you can see can trim down ripple voltages to precise rock steady value. So now things get complicated. We are now in the realm of integrated circuit. So you can see inside this single IC how circuitry is there. How many resistors are there, how many capacitors are there, how many transistors are there, and then they are doing their function appropriately. So that is what the beauty of the ICs. That is what the beauty of the electronic circuitry. And because of electronic circuitry, we can see some miniaturizations, and we can see the better efficiency of the electronic circuits. So as we know that the most common voltage regulator are, so that is the number of IC LM78XX. So for the plus voltages, and LM79XX for the minus voltages. So XX represent is the voltage you can see here. This may be the question for any of the net. What does mean, what XX represents in this particular IC? So XX represents the voltage. You can see 7815 is 15, like plus 15. 7915 is the minus 15. 7805 is plus 5. Means how much voltage regulation can be done with the help of that IC. So this last number decides. So typically needs input greater than 3 volts above output voltage. So here we are having the pin configuration 1, 2, 3. So here how it is connected. So simply you can see the like application of these ICs. Now this is what I hope you got the insight about the diode. You got the insight about like simply how do we use PN junction diode for different applications in electronic circuitry. But along with PN junction diode, there is another semiconductor component, and that component is the transistors. And if we see the transistors, then like in diode, we are having two legs. But in transistor, as I have just drawn earlier, here instead of only PN, another PN, another like a here simply if I draw this roughly, so you can see we are having this like this is a P, this is again N, and this is the P. So that is what we can say like a PNP or NPN. Anything is here we can see two different symbols of the PNP and NPN transistors. And then again we are having different biasing for this transistor. Or again if we see the basic of this transistor, then we have to remember there are three different regions in every transistors. Here you can see this emitter, E is nothing but the emitter, B is the base, and C is the collector. And again, if we see the size of the emitter, so size of the emitter is always moderate. So this E is always moderate. Base is always thin. यहाँ पे अपन ने वैसे निकाला नहीं है, but we have to. So this is the base that we have to draw like that. And collector must be always greater. So the size of the collector must be the more, not like a less. So ये तो delete करना पड़ेगा this one. Got it? So in that way, we are having the like a size of the like emitter, base, and collector. Another important parameter whenever we are discussing about the transistor is the doping concentration. And if we see the transistor, so in transistor, emitter is heavily doped. The doping concentration of emitter is heavy, whereas base is lightly doped and collector is moderately doped. Then again, there are certain reasons. Simply, the name emitter is emitter emits the charge carriers or the electrons or the holes, whereas base passes from emitter to collector, and collector collects the carriers. So in that way, they have their function, and because of that, we are having their doping concentration as well as the size also. So simply we can see the transistors are versatile, highly non-linear devices. They are the versatile devices, and which have several applications, beautiful applications like amplification, buffer, switches. Other than that, also there are like the X signal, as we know. So we are using logic gates, but logic gates can be made up of the transistors. So in that way, there are n number of applications. So the two frequent modes of operations, as we know, the again now we are having three legs, which means that we have to use two different power supply. And for normal operation, we can use emitter to base junction is forward bias and base to collector junction is reverse bias. As I have mentioned, for normal application, not for every application. So, but again, then we can make like a emitter to base junction reverse bias, base to collector junction forward bias. So that is also possible. So in that way, the possibilities are more, both like forward, both like a reverse. तो यह भी possibility अपने पास है. So, but better for normal operations, we can keep emitter to base junction forward bias, base to collector junction as a reverse bias. Then again, here, as I have mentioned, two main flavors like NPN, more common transistor, or the PNP, describing doping structure. So also many varieties, as I have mentioned, the bipolar junction transistor, it has two types, NPN and PNP. Another one is the unipolar junction transistors, and unipolar junction transistors can have the type like a field effect transistors, we call it the FET. Then it has again N channel and P channel FET. And again, another category is the MOSFETs. So metal oxide semiconductor field effect transistors. So we will just hit the essentials of the BJT here. So MOSFET in, so we'll discuss MOSFET in next lecture. So again, because it's a different one. So now here we can see BJT. BJT means bipolar junction transistor. So as I have said you, if we are talking about bipolar junction transistor, then again there are two types of the bipolar junction transistor. One is the NPN, another one is the PNP. And if we talk about NPN and PNP, then we can just the difference is that only we have to change the biasing. So whether it may be the NPN or the PNP, both are working in a similar way. Only thing is that we have to change the biasing, the supply voltage we have to change it. So simply you can see central idea is that when in the right regime, the BJT collector emitter current is proportional to the base current. So again, we have certain equations for the transistors. We call it as a current equation, where we can have IE is equal to means emitter current flowing through emitter is equal to IB plus IC. Okay, that is what the relationship. But again here, if 100% current flowing through emitter, then only like a 99 to 95% current flows through collector, and the remaining 1 or 5% current flows through the base. And that is why the base is thin and lightly doped, and the collector is like a larger in size and moderate in dope. So that is again one of the reason. Again, another parameter we can calculate as a current gain for the common emitter configuration. We are having three different configurations also: common emitter, common base, and common collector configurations. So if we are having the common emitter configuration, then we know we are calculating the beta, and beta is like a current gain, and typically beta has value more than 100. It is up to 500 also. Then again, alpha is the current gain for the like a CB mode, and again it is always less than 1. And whereas like a gamma is the current gain for the common collector mode, and it is like a unity. It is always 1, and in that way that common collector configuration can be used as a buffer. It can be used as a buffer. Buffer means that is used in operational amplifier. Okay, that can be used in operational amplifier. okay, to pass output voltage from one stage to another stage. So in that way, we can have the buffer circuit, and buffer circuits are also mostly useful. So again, switching driving to saturations means again, so if we want to use the transistor as a switch, then again, if we see the output characteristics of the transistors, so I will show you the output characteristics of the transistor matters a lot. So here I am driving, drawing this. This is a V, this is a I. It's a simply output, and that characteristics is just like that. Okay, so. So that characteristics is just like that. Okay, so here just I cannot draw appropriately, but we can see. And now if we see these characteristics here, there are three different regions. This is the region number one. So we call it as the active region. This is a region number two. We call it as a cutoff region. Okay, so it is a cutoff region. And then we are having another region here, the region number three, इसके बीच में जो भी region है, that is the region number three, and this region number three is called as a saturation region. And then according to application, we can operate the transistor in a typical region as per the requirement, as per the desire. So we can operate the transistors in a different regions. So then again, we can use transistor as a buffer, as I have mentioned. So when we are using transistor as a buffer, then we know we want a unity gain transistors where we calculate the gamma. So there are certain parameters we can calculate, and then again accordingly we can have different applications. So here you can see the improved Zener regulator. So if we are using the improved Zener regulator, then we can use what we can use. We can use the different we can use different circuitry, and that circuitry will be useful. Useful for what? Useful for the regulation of the power supply. And as I have mentioned, the regulation of power supply is most important in any of the electronic devices. So in that way we can move ahead. So then again, like a switching power supplies here, simply you can see power supplies without transformer. Now what is it comes? So if we see the charger, if we open the charger for the mobile, then there is no transformer, or the like a routine transformer is not there. So now how do we make it? So how to convert how to step down, then how to convert means how do we convert like a step down voltage to AC to DC. So these are the reasons, and in that way we can just calculate, we can convert also. So this is what like a simple power supplies without transformer. So we'll discuss in next lecture how these circuitries are used and how to calculate these all calculations. So here for today's session, I wish to stop. So just I want to recall what we have done in today's session. So friends, we have begin this session from the basics of electronics, and when we discuss the basics of electronics, then I have just distinguished the electronics from the electrical, and how the electronics word is differ from the electrical. So only the word or only the device power supply distinguish the electrical from the electronics. And in that way, we have discussed the first important component of the electronics, that is the diode, and again the functions of diode, how it can be operated, how the characteristics of the diode or the VI characteristics in forward bias and in reverse bias. Then after diode, we have just discussed about the transistor. So how the transistors are differ from the diode. So diode is simply PN junction, and again in diode, as we know, we are having PN junction, but again there are different types of the diode. One is the PN junction diode, or we call it semiconductor diode, then the Zener diode, then the variac diode, or the tunnel diode, or the photodiode, and every diode has its different functions. So these functions are simply you can see here, Means diode has different functions, and that functions we have discussed how a diode can plays a major role in the process of rectification, and how rectifiers are used for the electronic devices. Without rectifier we cannot use the electronic devices like a computer or like a television or like a radio, or I mean there are so many devices which we cannot imagine without power supply, and in power supply diode plays a very vital role. Then we shifted from diode to somewhat towards the like a transistor, and again we have seen how transistors are important, how transistor plays the role in like a, in amplification and in some of the other applications like a buffer and like a buffer. Then the how do we operate transistor as a switch, how to operate transistor as a switch. So these all things we have discussed in today's session. So with this note, I wish to stop for today's session. Again, thank you, Bharti, for giving me an opportunity to discuss the basic concepts of the electronics, and then tomorrow we'll be discussing some more as per the syllabus. So once again, thank you, my dear friend Rajiv Gandhi sir, for inviting me, and all the associated faculty and the resource person and the members of the BARTI for giving me an opportunity. So once again, thank you, thank you. So Dr. Nilesh Ugemuge signing off.